I don't have a joke to start us off like Chad did, but and I know we're getting late in the day. So we've talked a lot about plugins today, but I think that really speaks to the versatility of QGIS and the beauty of open source in general. That you can add your own functionality and customize it to what your use case is. So I'll be talking about a plugin that I've worked on called the EcoValuator. But real quickly to introduce myself, I work in the Science and Engineering Library at the University of Virginia in Charlottesville, Virginia. Basically, part of what I do is help people with research projects, and mostly that's related to GIS projects and then Python-related scripting and programming. I've been a GIS user since 2006, and I do GIS projects on the side, which is what I'll be talking about today. And I pretty much use all open source GIS these days. And then I like to rock climb and generally be outside in my free time. And that's what I was doing last night instead of coming to the happy hour. So anyway, we've talked a lot about plugins, like I said. This is just a screenshot of the plugin menu. You can build plugins for internal use or for the world. And if you upload them on the QGIS public repository, this is what you see. And like I said, this is part of the beauty of open source. You can customize things to your own use cases and extend QGIS capabilities. So I don't work for Keylog Economics, and this is not a sales pitch for them, but basically a colleague of mine, or a former colleague of mine, is an owner or operator of Keylog Economics, and they're basically an environmental economics consulting firm. And my interpretation of what they do is they try to prove that saving the environment makes economic sense. So I'll tell you about this plugin real quick, and I know there's a lot of text on this page, but we'll get into some demo later. So the EcoValuator plugin was originally funded by a grant from the National Fish and Wildlife Foundation. The first round of development was in 2018, last summer, like 2 summers ago, I guess. And I jumped in this past winter, in the winter of 2019. And I wanted to define a term for you real quick. So ecosystem services are the many and varied benefits that humans freely gain from the natural environment and from properly functioning ecosystems. So basically the monetary value that nature inherently provides for us. And there's many different ecosystem services. So some of the ones that this plugin deals with are the aesthetic value of the land, biodiversity value of the land, erosion control, protections from extreme events, and so on. There's about 16 ecosystem services that this plugin allows for. And then basically the QGIS EcoValuator provides a simple means of estimating the dollar value of different ecosystem services for the land cover types in your study area. And the EcoValuator then does the work via a 3-step process to take your data and generate a meaningful representation of it to share with your stakeholders or with yourself. So a little more background information. Python and QGIS. Python is a free and open source programming language used for a huge variety of purposes, for scripting, for more in-depth application development, things like that. Widely used by GIS practitioners today. And then the QGIS Python API, also described as PyQGIS, is the basically intermediary that allows Python and QGIS to talk to each other. So you write some code in Python, and then you can make QGIS do stuff with it. And I've linked to a lot of these documentation pages and stuff. I'll talk more about that later. QGIS plugins are written in both Python and C++. I think they're mostly just written in Python these days. Anyway, there is some good documentation at the QGIS.org homepage. In particular, the PyQGIS Developer Cookbook. I also referenced one of the books that was given away earlier, written by Gary Sherman, sort of the godfather of QGIS. It's something like the PyQGIS Developer's Guide. I forget exactly what the title is. I referenced that a lot as well. But basically when I signed up for this project, I had no idea what I was doing. I didn't know what the plugin architecture was and all the files and stuff behind it. And I signed up for this as a learning opportunity. And I'll talk some more about my struggles at the end of this. So let's talk about what the, well, talked a little bit about what the plugin does, but each step, there's 3 steps in the process. So basically you input your land cover data and your area of interest or your study area. So the study area is just a vector polygon geopackage or shapefile of your study area. The land use land cover data, you can either use the National Land Cover Dataset or the North America Land Change Monitoring System. I'll tell you a little bit more about those. But basically, so I've got a screenshot of the NLCD dataset right here. This is United States, including Alaska and Canada. Basically what it does is breaks down the US into 30 by 30 meter pixels. Each pixel has a land cover type. So as you can see, there's desert land cover types, urban, forest, swamps around the side. I think there's always forget, 19 or 21 in total. A couple only exist in Alaska, like there's some alpine tundra and stuff like that. The second step, you choose the ecosystem service you want to estimate your value for, and the third step produces a nice looking map as output. So in lieu of a live demo, I'm just going to walk you through some screenshots of a live demo. I've learned that live demos are fraught with problems sometimes. And then actually the current state of the plugin, it's kind of broken, so but that should be fixed soon. So it's kind of in disrepair at the moment. But I'm going to be using the NAL-CMS data, so that's North America Land Change Monitoring System. And this is roughly equivalent to the NLCD data set, except it applies to the US, Canada, and Mexico. So the area of the area is expanded, area of use, and the land cover types roughly translate to NLCD, but they're somewhat different. There's some desert ecosystems in Mexico that don't exist in the US, and then there might be something in Canada that doesn't exist elsewhere. I forget exactly. And then my study area is Chesterfield County, Virginia, which is basically part of the Richmond, Virginia metro area. It's sort of on the south side of the city. So step 1, basically what this does is I have my input layers. So the land use land cover data set, which is NAL-CMS in this case, and then Chesterfield County. So when I run this, I clip the NAL-CMS data set to the extent of Chesterfield County. And then I also generate an output table, which you see at the top. So a little bit about the output table. So I was not a part of this process, but basically, as I said, we're estimating the value of each one of these pixels in Chesterfield County. And based on the ecosystem service that I choose, we're getting an estimated value of that pixel, an estimated dollar value of what that pixel is worth. And this output table at the top basically is a comprehensive table of the minimum, average, and maximum estimated value for each land cover type for each ecosystem service. So that's kind of hard to wrap your head around. But for example, because I've clipped this entire land use land cover data set to Chesterfield County, you can see I've got 10 rows in my output table. So there's 10 land use land cover types in Chesterfield County. And that just depends on where your area of interest is. And then I've got the estimated dollar amount for each ecosystem service for each land cover type. And as you see, so first of all, there's none or no data values in there. I was not a part of basically the process to estimate these values. The people at Keylog Economics reference government documents and then other scholarly publications and stuff like that to do their best to estimate what a pixel is worth for each land cover type. I just took those values as they were given to me. My natural reaction to them was a little bit skeptical, but I took them for what they're worth. When I run step 2, so in this example here, I'm estimating the average, average biodiversity value of all the pixels in Chesterfield County. In retrospect, I maybe should have chosen something that looks a little more interesting, but basically my output of step 2 looks like this. So I've got Chesterfield County, and then as you can see in my legend up here, I've got the range of values for Chesterfield County as they relate to biodiversity, and then they're shaded accordingly. So basically, these are, like the areas you see in green are all around water, so those represent high biodiversity value. The rest of the county either represents no data or low biodiversity value. I'll show another example to you next slide that's a little more interesting to look at. And then step 3 is a nice looking map as your output. I'll talk about some of my struggles in the process. Actually, so basically I created a template using the print composer and did this using Python. And I struggled a lot with this. But basically you can customize this to look any way you want if you know how to use the print composer. But one of the asks from the Keylog economics people was just let people press some buttons and get a nice looking map as your output. But as you can see, elements of the output map were the main map in the foreground, these title and subtitle, some credit text in the bottom right, and then the legend in the top right. The legend was also really tricky for me to figure out how to make it work. Basically, the way it works now is all the active layers in your map are going to be in your legend. That was easier said than done. I'll put it that way. So I put this other example in there as a nicer looking map output. This is the Roanoke River Basin, which is in Virginia and North Carolina. And we're also looking at the average biodiversity value. So this one has a lot more lower biodiversity values, and I think it just looked better in general. But you see the output for Chesterfield County as well. So future work, actually integrating the NAL-CMS dataset is going to be released shortly, probably within the next few weeks or so, once we figure out what's broken with it. And then Keylog economics, the reason, long story short, the person I was in touch with likes to work in developing countries, and they want to expand the capacity of this plugin to work in developing countries, but land use land cover data doesn't exist in a lot of those places. For example, he lives in Vietnam. They have future use cases in Vietnam. So maybe when that data comes together, we'll expand future use. And then I wanted to talk about some of the challenges I ran into developing the plugin. So like I said, I basically took this on as a learning experiment. I had done scripting, but had not really done anything sophisticated in QGIS with Python. So first of all, I was working on this 6 to 9 months ago, and I will say the documentation, the PyQGIS documentation has come a long way in that time. But I ran into a lot of roadblocks in what documentation was available to me. I briefly mentioned the PyQGIS Developer Cookbook to be in one of the earlier slides. This was a really good resource to get me started. It provides a lot of examples of really common use cases, but once you get into customizing things further, you were kind of left to your own devices. And I think this is an open source issue. Obviously, QGIS is an open source effort. No one's being paid like they are for Esri to write really thorough documentation. And it is I want to get involved in writing documentation. I should have already, but I'm going to do it. But just to give you an idea, this is an example of a documentation screenshot I took from ArcGIS Pro. And the point here is that they give you code examples, which is hugely useful. QGIS documentation, or PyQGIS documentation, tells you how to use different functions and things like that. But a lot of times you have to set up objects and things like that to be able to use a tool, and I really struggled there. So in my experience so far, the PyQGIS documentation is lacking those code examples. So I was left to Stack Overflow and other blogs and things like that. I'll talk about that next. But in conclusion, I'd like to thank the QGIS user community, in particular Niall Dawson, Anita Grasser, and And then this mystery guy, Ben W., that's his Stack Overflow username. But they took time out of their own lives to help people like me asking questions on Stack Overflow. If you're not familiar with Stack Overflow, it's basically a community question answer tech-related site. Also at this time in the development and the timeline of QGIS, so QGIS 3 had rolled out summer of 2018. I think when I was working on this project, we were at version 3.4, which is still the current long-term release version. But basically, there were limited code examples for QGIS 3. A lot of them were from QGIS 2, which I could adapt. Sometimes there just were not examples out there. So I had to figure it out myself. I actually wrote a couple, like for example, let me just roll back here real quick. When I created the legend, like I said, you get the range of values symbolized as equally spaced quintiles. So depending on the value range of your study area, you'll get 5 evenly spaced quintiles. That was really difficult for me to figure out. Long story short, no data values were a real issue because they got a value of $255, and that was being interpreted as $255. So basically, I wrote some a blog post on how to create this map symbology and stuff. And I've had people email me and contact me on LinkedIn and stuff from literally all over the world. Just like Niall and other people, Ben W. in particular helped a lot. The QGIS user community has been hugely helpful and supportive to me. I'd also like to thank Keylog Economics for letting me get involved. Phil Ribbons and Elliot Kurtz, who are the other people working on the development of this project with me. And then Randy for organizing this, because I'm sure it's a thankless task. So any questions?
So I have a question about the data. We just showed the evenly spaced scale, right? But clearly, one of the bins is dominating all the other values. So first thing, look at the histogram of those values. You can do that in QGIS, and you'll see that it's probably shaped like that, right? So that's a power law distribution. So what you might want to do, just for shits and giggles, is instead of evenly spaced bins and looking at the quintiles, do a log transform of the data, and that way the stuff that's basically hidden, that's all kind of washed out, is going to pop out, and you see some hidden structure that it was difficult to see there. Second, I think it's surprising to me that, and this is not anything I knew, and it's on the documentation, that you have something called a cookbook that to me doesn't behave like a cookbook. If you go to the O'Reilly online book seller, he has like Python cookbooks, R cookbooks, and all of those are a collection of recipes where a recipe is, I just want to do this one damn thing, and it shows you an example. Just copy this code, and if you are interested in the details, here's a description that goes into detail how the code works. And you basically just copy and paste it. So when I see cookbook, that's what I expect to see. In other words, I expect to see what you wanted, which is actual code examples that you could actually copy and paste and hack to fit. So I find that to be a little surprising that you have a cookbook that doesn't seem to be behaving like a cookbook. It's more like just an API documentation.
Well, to be clear, the cookbook is little code snippets like that, but
Okay.
it is limited.
Oh, I was confused because what you have there, I thought that was from. Okay.
Yeah, just to be clear, this is just a screenshot from the QGIS documentation.
Right.
The cookbook does have those little code snippets, but there's only so much in there,
Okay.
and it's relatively basic things,
Right.
and they were hugely helpful. But in the documentation, once you get a little bit more in depth, a code snippet would have been really helpful, which is why I want to get involved with the documentation.
Right, so I think the rule of thumb is if you have to go to Stack Overflow and you find your answer there and it wasn't in the cookbook, then that's like a cache miss. And you can go back in the cookbook and basically splice in a recipe that you got from that Stack Overflow.
Anyone else? Okay, thank you.